Hey there, physics. Sorry that this is super last minute. I will send out an email to like remind people this is a thing that's happening. I wanted to put one more grade on the marking period for juniors. Seniors, I know that you have a little more time in your marking period, but I wanted to sneak this in because it's kind of a last final thing with waves. Normally I do this like beforehand, but again, timing, pandemic, it's all been funny. I brought up the wave simulation again because this is the only way I can think of to describe it for fully remote students, or for anyone uh, who hasn't been in class or who wasn't in class to do the lab. What we did was something similar to when I did the wave demonstration with the big slinky. I had these kind of smaller springs, but they were a little tighter than a slinky would be, and I say lab, it's really more of like a calculations exercise. I wanted y'all to find the velocity of a wave on this spring. All right. Now, in order to find velocity, and if I flip back, there it is. So for waves, for other stuff like velocity is just distance divided by time. But for waves, velocity is frequency times wavelength, right? So frequency is how many waves go by per second. The wavelength is literally how long is the wave. In terms of this, what we did in class, what we did in person, was it was basically groups of three because we needed two people to be holding and moving the spring and one person to be counting or taking a video and then counting. So we had two people on either side holding the spring and they moved it back and forth, right? As they moved it back and forth, they made a pattern, right? They tried to what I had them do was try to make uh oh, that's too well, this is almost one wave. I wonder if I can. No, I don't want to do that. Stop it. Nope. Uh that's too much. So this I wanted them to make like half of a wavelength, which would be like that. It would just be like this going back and forth, right? It would be half up and then half down, and then half up and then half down. It would just be like that. I wanted them to make kind of one full wavelength. Actually, that's closer to one. Oh, man, I wish that I could. Okay, wait. That did not do what I wanted to do. Also didn't do what I wanted it to do. The limitations of online simulations. Alright, if you guys see this, this is one, two, this is like 1.5 waves. I could change it to be, it's pretty close to just one wave, right, if you look at it. It's an up and a down. Uh, if I go, it's pretty close to two waves, up, down, up, down. I'm trying to, oh, actually I could just do this. Yeah. So up, down, that'd be two waves. And I also tried to make them do, ooh, yep, real slow. So there would be like half a wave. Let's get rid of a little bit of that dampening. So that'd be half a wave, right? So I had them try to do this in person, and it was a little difficult in person because like physically, you have to move the spring back and forth. This was easy, right? It is fairly slow. It's very, very boring, right? And then trying to have them make one wave was actually pretty straightforward, right? That looks like that's one wave going. There's it's a little clearer if I slow it down. I had them go 1.5 waves and started to get difficult to hold on to the pattern for 1.5 waves to make a up down up or a down up down, right? And I hope that you can tell that this is 1.5 waves, right? So it starts one there to there. That's about one wavelength right there. And then here's the last half. It's very difficult for them to get 2 full waves. And it's difficult here to like, you can see that it gets more difficult to maintain. And that's because you have to shake it back and forth. Right, so the frequency would be counting. So 1, 2, 3, 4. But they had to count it out, right? They didn't have an exact frequency like we do. They had to count it out. 1, 2, how many times does it go back and forth? The other thing that they had to do was determine what was their wavelength. So they sat a certain number of squares away, they measured the square, they figured out, okay, we're this far away from each other, right? And using the frequency that they calculated by counting out per, what's it called? Per like 10 seconds or 5 seconds, 20 seconds, and then by seeing, okay, well, if we had half a wave and we were 2 meters apart, then that means that a full wavelength would be 4 meters. If we had one full wave and we were 2 meters apart, that means our wavelength was 2 meters, right? So they can calculate their wavelength. So they had frequencies, they had wavelengths, and what they had to do was calculate what is the velocity of this wave every time. I wanted them to compare it. And something curious should have happened, right? If everything was perfect in a perfect world, what should have happened was every single velocity should have been basically the same. And the reason for that is every single one of those waves was traveling in the same medium from... what the devil is going on? Sorry. Not you guys. Wait. Something is happening. Okay. But it was because the spring, right? The spring didn't change. I told them to stay the same distance apart, so the tension in the spring didn't change, just like the tension. So the tension in this spring is high. The tension in this string is high. And that was intentional. If they changed the tension of the string, it would become easier or harder to create those waves. And the friction between, they were on the ground. So the friction between the spring and the ground also didn't change, right? Because of all that, it all really should have been the same. Now, was it always the same? No. But a lot of them were pretty darn close. What I'm going to do for you, fully remote students, or anyone who hasn't been in class or wasn't in class today, I'm going to post some numbers to my CBA, and I want y'all to do the calculations. Right? I'm not going to give you literally frequency and literally wavelength, because then all you would have to do is multiply them to get velocity. I'm going to tell you how many waves they counted in a certain amount of seconds. I'm going to tell you how far apart they were sitting. And I'm going to tell you how many waves they made for each trial. I want you to interpret, what is the actual frequency and what is the actual wavelength, and then calculate the velocities, and then just do a quick comparison of them. All right? If you have questions, please email me. Again, I'm going to send out a quick email to fully remote students and anyone who hasn't been in class to remind you guys to do this assignment, because I want it to go on 5th marking period. And I know it's late. It's Friday night, and marking period ended today. But I can take stuff until about Sunday. So if you need a day or two, just let me know. All right? There will be... Videos are going to be a little less frequent, just because we're done with new stuff, right? Waves was the last new stuff that I wanted to do. I'll obviously answer any other questions or other topics that you want to do, but we're going to go kind of backwards. We're going to do some more labs. So the videos will be more lab related, if anything, which is all I mean when I say they'll be less frequent. It'll just be as we do a lab, okay, I'll post a video about that lab. Yeah. Again, if you have questions, let me know. Otherwise, I will see you next time. All right. Take care of yourselves, and be good.